I'm now going to work for you the characteristics and representations of functions section of the MPA2. Make sure that as I'm working these for you that you are using your correction sheet for the ones that you missed to make corrections and to work the problem correctly with work shown. Then pause the video and make sure you fill in the part where you say something that is not correct with your original answer. I'm not going to give you credit unless you've completed both steps. So any work I'm showing you right now, you should be writing down in the work section of your correction sheet. Then when it says why your answer is not correct, make sure that you have something written down. So it says here the diagram below shows a ramp to the entrance of a store. What is the slope? Remember that the slope is also known as the rate of change. And remember that your rate of change is your change in y over your change in x. Our change in y is our up and down change. Our change in x is our left to right change. So in this case, I need to put 3 over 12. This is slanting upwards from left to right, so it's a positive 3 over 12. 3 over 12 simplifies. So I can divide both numbers by 3. 3 divided by 3 is 1. 12 divided by 3 is 4. So the answer should have been C, 1/4. This would be the time now that you need to pause the video and fill in the part of your correction sheet where it says, why is your answer not correct? So for example, maybe you said it was B, negative 1/4. Well, you would write in the why is your answer not correct section that you picked a negative slope when it's really sloping upwards. Or maybe you picked 4 over 1, which means that you put the change in x over the change in y instead of the change in y over the change in x. Either way, make sure that you're actually filling in both parts of your correction sheet. Number 2 asks which equation is shown on the graph below. All of these equations are in slope-intercept form, which remember means y equals the slope times x plus the y-intercept. So the second number right here, the y-intercept, tells us where the graph hits the y-axis. So the graph hits the y-axis right there at a positive 1. That means it can't be B because it's got a negative 1 for a y-intercept. Can't be D because it's got a negative 1 for a y-intercept. You'll also notice that the graph is slanting downwards from left to right, which means it's going to have a negative slope. The number in front of the x is the one that tells you your slope. A has a positive slope, so it can't be that one either. So it has to be C. Y equals negative 3x plus 1. Next up, we've got which equation best represents the relationship between x and y in the table below. So remember this number in front of our x is our rate of change, aka our slope. So I would probably start by finding the rate of change of the table. I'm going to knock out D actually first because this exponent right here at the x means that this is not going to end up being a linear function. And actually, let me show you really quickly before I roll that one out. Y D is not going to be right. So I'm going to find my rate of change. Let me get this out of the way here. Remember that our rate of change is our change in our y values over our change in our x values. So this is going up by 3, 3, 3, and 3. This is going up by 1, 1, 1, and 1. So I can tell because I've got a constant rate of change because it's always 3 over 1, because remember it's my change in y over my change in x, and it's the same all the way across. Because it's a constant rate of change, I know that this is also going to be linear, which if I were to graph this function, it would form a straight line. Okay, this guy right here with the exponent and this guy right here with the exponent tells me that C and D are both not going to be linear. If you have an exponent right here for the x squared, it's not going to be a linear function. which means it can't be C or D. So again, the fact that I have a constant rate of change in my table tells me that it's going to end up being linear. And the fact that these two equations have an exponent means that they are not linear, so they can't be the right answer. Now I know my rate of change is a 3 over 1, which is a 3, which means it can't be A, because remember the number in front of the X is your rate of change. So that means my answer has to be B, because it's the one that has a 3 in front of the X, which means that its rate of change is 3. I'm going to show you another way, though, that you can double check that, just to make sure that you did it correctly. So if B is in fact correct, that means that I should be able to take that equation, so y equals 3x plus 5. I should be able to take a pair of values, so in this case 1 and 8. I'm going to put the 1 in for x, the 8 in for y, and it should balance out. So instead of 3 times x, I'm going to do 3 times 1, which is 3. 3 plus 5 is, in fact, 8. So this point works. I'm going to test one more just to make sure. Never hurts to double check your answer. So I'll check, let's see, this 3 and 14. So I'm going to put in, because my x value is a 3, I'm going to put in a 3 for x. My y should be a 14. So 3 times 3 is 9. 9 plus 5 is in fact 14. So that's another reason that I know that B is my answer. Number 5, which value will allow the ordered pairs to represent a function? So we've talked before, let's say that this is our function. Y equals 2x. So that means whatever you put in for x, otherwise known as your input, you're going to multiply it by 2, and out is going to come your output, also known as your y. So if I put a 4 in for my input, 2 times 4 would be 8. If I put in another 4, I'm still going to get another 8. I could put in 4s all day long. As long as this is functioning correctly, I'm always going to get an 8. Remember, for it to be a function, if I have the same input, it has to have the same output. So let's look at all of my possible answers. So A, for example, if I put A in for K, in that case, I'm going to have 2 of the same input, because they're both going to be 1s. Remember, the input is the x value, but then they're going to have a different output to go with them. That won't work. Same thing would happen if I put a 2 in for K, because I would have 2 2s for my input, but then they would also have different output. One is a 6, one is an 8. So that means that that one can't be it. I would have the same thing happening if I had a 3 in for K. So I would have 2 3s for inputs with different outputs. So the only one it could possibly be is D4. So if I put a 4 in, then all my inputs would be different. I would have a 1, a 2, a 3, and a 4. So as long as all your inputs are different, then it is in fact a function. So my answer is B. Based on the situation for number 6, which of the following is going to be true? So we're going to look and see the students had 42 books all together on the 5th month. All together means if you added the 2 students together. So let's look on the 5th month and see how many each of them had. So both of them had 42. So that would be 84 altogether, because one of them has 42 plus the other has 42. So altogether, they would have 84. So that one's not right. The correct answer is B. They each had 42. And you can tell for sure that that's right also. Okay, Janice owns 17 and then bought 5 each month. So right here it's showing Janice, and every month it's going up by 5. So that by the time she gets up here to the 5th month, she's got 42. So she's got 42 all by herself, which means it couldn't have been A. Okay, for C, each student owned 27 on the 2nd month. If you go up to the second month, now one of them has 27, but the other one has like 30 something, so that's not right. The students had 27 books all together before the first month. Well, before the first month even started, Janice had 17, and then Eunice had 27. Well, altogether, 17 plus 27, that would actually be 44, not 27. So for those reasons also, B has to be the right answer. Moving on to number 10. So all of these equations are in the format where the number in front of the A is your rate of change. So I'm going to figure out my rate of change here. So remember, it's your change in your Y over your change in your X. So these are going up by 2 every time. My X's are going up by 1 every time. So my rate of change is 2 over 1, which simplifies to a 2. So it has to be B. But I'm going to double check and make sure. If B is in fact correct, that means I should be able to put a number in for A, age, multiply it by 2, and then add 3, and get H, the height of my tree. So I'm going to take, let's see, I'll just take this set right here. So I should be able to put a 7 in for A and get a 17 out for H. So let's see. Instead of 2 times A, I'll do 2 times 7 and get 14. 14 plus 3 is, in fact, 17. So that's another reason that I know that B is the right answer. Number 11. So Maxine increased her speed as she entered the highway, then drove at a constant speed, and then slowed down to exit the highway. So which one represents that? So this one shows a gradual increase. The flat means she traveled at a constant speed, and then she slowed down. The answer is A. So we're asked to figure out which table matches the graph. So our X value, so what should be along the bottom is our number of buttons sold. Our profit should be on our Y-axis. So I'm going to look at my first point. So I'm looking for one where the number of buttons is 1 at the same time that the profit is 2. So number of buttons 1, profit 2. Nope, that's where that point should be. And that point doesn't fall on the line, so it can't be A. Let's see, number of buttons is 1, profit 2. Nope, that one doesn't fall on the line. Number of buttons 1, profit is 2. Oh, there's one where it falls on the line, so that could be it. Number of buttons 1, profit is 2. Nope, doesn't fall on that one either. It has to be B. Let's just double check to make sure here, because we should also have the point 2, 4, so over 2 and up 4. Yep, it's on there. Then over 3 and up 6, and then over 4 and up 8. So yep, B is in fact the right one.